everyone. Today in our video, we are going to walk through this Elastic blog post to build a smart real estate search app. And it will combine the geospatial and hybrid search power of Elasticsearch with GenAI capabilities of Amazon Bedrock to create accurate location-aware RAG applications. So let's dive in. The workflow, which is described right over here, is very straightforward. So when a user asks a question, the application first uses the Amazon Bedrock model like Claude Sonnet to perform named entity recognition or NER, and it intelligently pulls out details like property type, address, desired features, and also generates embeddings of keywords. Next, it sends the extracted addresses to the Amazon location services, and that returns the precise latitude and longitude. And this is where the magic happens. The app sends a single hybrid query to Elasticsearch and combines the keyword search for property type, semantic search for features, and geospatial filter to find listings only within a specified radius. Finally, these highly relevant location-aware results are then fed back into Bedrock as context, allowing the AI to generate a helpful and accurate answer based on real-time data. Let's go to the README file, which you can actually find from this example code snippet, which is mentioned on the blog itself. And over there, you will find step-by-step instructions on how to implement this. So the first step is really to get into the AWS EC2 console, where you create the instance and you choose the Amazon Linux platform of your choice. And the most critical step will be to assign the right roles so that the IAM role, so that you have the correct permissions. And this is how the application will securely access other AWS services. So the role needs two policies, which is the Amazon Bedrock full access policy. And it also needs the second policy, which is mentioned over there, so that the app can talk to Bedrock and the location API. So I've created the instance and I have assigned the policies, the Bedrock full access, as well as the other policy that was mentioned over here. The next thing you also have to make sure is the security groups and to enable inbound traffic for port 22, as well as for the Streamlit application, which is 8501. So once we've done that, I think we are pretty much set on the EC2 front. So we can go ahead and now make sure that you're copying the cloning the repo first, and you are now able to go into your Elastic Cloud account. And if you're familiar with the Elastic Cloud account, this is the console, and you go into Dev Tools, and as the README suggests, we need to copy all of the contents from this file, which is the data loader elastic console.txt, and paste it into the dev console. So that the first command that helps you set up that inference endpoint, this is what allows Elasticsearch to talk directly to Amazon Bedrock. And when you paste this in, you must replace the placeholders with your actual AWS access key and the secret key. So don't forget that. Next, we'll create our index. And this mapping is crucial. We define a geopoint for our coordinates, as well as semantic text type that tells Elastic to automatically use our Bedrock endpoint to create vector embeddings for this text. Finally, we'll load our property listings, which are all the rest of the file that you see here. So once you're done with loading all of the property listings and all of the data is indexed, the vectorization happens automatically in the background, and it's incredibly efficient. So that's the rest of the files that need to go into Elasticsearch. And finally, you can execute the sample hybrid query to test it out. So now moving into the application code. So now the environment and the database is ready, and we can run the application. So first, let's SSH into our EC2 instance. And once you're done with SSH, you have to make sure that you clone the AWS sample repository, of course, and you install all of the requirements from the requirements.txt file. And I have already done all of that. The important part over here when you're doing that is to make sure that when you are actually updating the Python file, you update the cloud ID with the cloud ID of Elasticsearch, the cloud API key, as well as the index name from Elasticsearch, and also some of the models need to be updated to whatever you are using. So going back to this, we are going to finally, after all of the updates are done, now we are ready to launch, right? So we'll run the Streamlit command and what it'll do is it'll open the browser tab. So I'm gonna go ahead, I've already SSH'd into my EC2 instance. So I'm gonna go ahead and run this. And this is going to give me the external URL. And look at that. We have our app, our geospatial RAG in action. So let's try that. It gives me some sample prompts, which I can just take, for example, finding townhomes near Apple campus. So let's do this. Look at that. It's unleashing the power of Elastic's hybrid geospatial RAG app. And at this time, it's using the location services. And it's almost there. We're looking at the Bedrock LLMs, which are at work. And there you go. It has provided me a full response. It correctly extracts the entities, finds the properties in the right area, provides a perfect context-aware summary of the findings, mentioning the specific features we asked for. And the map also gives us that instant visual reference from where the properties are located. And this is the power of hybrid geospatial RAG in action. So let's recap. By combining the power of Elastic's advanced search capabilities with Amazon Bedrock's powerful generative models, we built a truly intelligent application. It understands user intent, it leverages location, and it provides accurate, trustworthy answers by grounding the AI in your real-time data from your database. So the architecture eliminates the guesswork and hallucinations often associated with GenAI applications, delivering a superior and more reliable user experience. You can build this entire application yourself, and for the complete guide, just visit the post on Elastic Blogs, and you can find all of the code and configuration files in the AWS samples repository in GitHub. Thanks for watching.